So, welcome to this. This is the Further Math Support Programme online revision session for Edexcel Statistics 1. In this session, we are going to be looking at measures of central tendency and measures of dispersion. So, looking firstly at measures of central tendency, these are effectively your averages. They're the means and the medians. So for the mean, you need to be able to find it from a list or a stem and leaf diagram, also a frequency table, and also you need to be able to estimate the mean from a grouped frequency table. And the reason we're estimating is because you don't actually know your data because it's grouped. We also need to be able to find a median, again from a list, from a frequency table, and then we need to be able to use interpolation to estimate the median. And again, there are a few issues that we need to be aware of with this, certainly looking at mark schemes, and I'll address that when we get to the question. Measures of dispersion are basically your standard deviation, so you need to be able to find that, and also your interquartile range. They're the two that we use. So you need to be able to do those. Also, draw box plots with the added bonus of having to deal with outliers. You need to also discuss skew. You don't need to learn measures of skew, because if you need to use a measure of skew, there are so many, and they'll tell you in an exam which one to use. If you do use one because it's easier for you to discuss, brilliant, but there's no obligation to do that. Also, you need to be able to understand histograms and interpret them. Rarely are you asked to draw them in an S1 exam, but you may be. So, let's start looking at some questions. Now, this one is a good example of making sure you read the question. So we're asked in this question to calculate the mean amount of rainfall during the whole 28-day period. So we need to read the question and understand what's going on. So first of all, we can see that we're going to calculate a mean. However, we need to realize that we're talking about 28 days, and this value here, although it's notated as sum of x, is only for the 21 days that Jenny records the amount. So really, to calculate the mean, we need to realize that it's the 84.6, but also we need to add in what Keith got. And if you add all of Keith's together, you get 22.4. So the actual sum of x that we're dealing with will be 107. So to calculate the mean in this particular case, it's going to be 107 over 28. Now, as you'll see in other of these presentations, that is actually a perfect answer. It's a fraction. Yes, it's top heavy, but that will be acceptable for the accuracy. Now, if you want to convert it to a decimal, you're more than welcome, and you get 3.82. So it's 2 marks for this question, 1 for working out 107, and 1 for doing the calculation of the mean. It then continues, and it says that Keith now realizes that he's got things a bit wrong. He's transposed 2 of his numbers. So 9.4 should have been 4.9, and 0.5 should have been 5.0. And what we've got to do is state, without necessarily calculating, although you can, state with a reason what this will do to the mean. Now, the way I approach this question is to realize that 9.4 take away 4.9 is equal to 4.5. 0.5 take away 5.0 is equal to minus 4.5. So overall, the sum of x doesn't change. Okay, and of course you can get to that by actually just redoing it, the whole calculation, with Keith's new numbers, and realizing you still get 107. So because sum of x doesn't change, x bar over sum of x doesn't change either. Okay, so again, there's a variety of ways of doing that, but that's quite a nice one. So 2 marks. One of them is for basically saying that there's no change to the mean, and the other one is to justify why. And this is one technique that we could use. So moving on, we've now got a question that looks a little bit more S1-like. We've got a data table, and when you read the question in full, there's lots of bits that you need to do. Now, when I look at this, there's 2 things that cross my mind. First of all, it's a frequency table. It's grouped, and that's the key thing. But more importantly, there are gaps in my data, and it's really important to recognize that. So for instance, the final group needs to go from 40.5 to 59.5 to compensate for that. Okay, so firstly we're asked to find midpoints. Okay, now to find a midpoint of a class or a group or an interval, call it what you will, you add the ends together and divide by 2. Now notice it doesn't matter if you do it using the values that we should use, we're still going to get the same answer. And you can fill that in on the table, okay? And we do that for each, and we're going to get a mark for each one. 31 plus 40 divided by 2 is also 35.5. And please fill it in on the table, there will be space. Examiners do go back and check these things to see whether you filled them in or not. If you just write them in the answer, that's fine as well, but it does help filling them in. So 2 marks, 1 for each aspect. So there we go, put them in. So the question continues now to estimate the mean and standard deviation. Now there are 3 key measures that we need here to do this. You need to know what n is, you need to know what the sum of all of your data is. So sum of x, but because it's a frequency table, we notate that as the sum of fx. And likewise, you need to know the sums of squares. But again, because it's a frequency table, that's the sum of fx squared. Now there are a variety of ways of getting these, including typing the table into your calculator and finding the relevant summatives. And that's absolutely fine, okay? But you need to be aware that some questions are designed where you can't do that. So in this particular case, n is 56. The sum of fx, again, you can either add a row and work it out, or you could just calculate it through. So that's what I'm going to do. You can do 6 times 5.5 plus 15 times 15.5 plus you add all of those together, okay, and that's going to give us 1316.5. Likewise, sum of fx squared, so please remember that's frequency times by the square of the midpoints, okay, and you do need to indicate that that's what you're doing. And again, if you add all of those together, we're going to get 37378.25. Now, as I say, these are the key measures. Okay, so I'm going to now work out the mean. So the mean is the sum of fx, in this case, divided by n, which is going to be 1316.5 over 56. And that's going to give me a value of 23.5. Now, please remember 1316.5 over 56 is not a fraction. So you do need to do something with it. So the easiest thing is to convert it to a decimal. Now, standard deviation. There are 2 issues here. Just put a box so we can answer that question. First of all, the formula isn't given, and it's hard to remember. So there is a way of doing this, and it's to recognize that sigma squared, which is the square of what we're dealing with, is equal to sxx, which is on your formula sheet, divided by n. So sxx is equal to the sum of x squared minus the sum of x squared over n. That's what's printed on the formula booklet. Now, you have to realize here that really, let me just change color, really you need to realize and see that because it's a frequency table, this is where some people get a bit sort of stressed with this, you should have some f's in there as well. Okay, so make sure that you're happy with kind of that notation. So we can work this out because we've got everything we need. We've got the sum of fx squared and we've got the sum of fx all squared. We can work that out. So let's consider sxx. So sxx is equal to 37378.25 minus 1316.5 squared over 56. Now the reason I like this method is if you've made a mistake calculating the mean because you've, say, divided by the wrong number, this allows you to redeem yourself a little bit because you're not really using the mean. So if we calculate this, we're going to get 6428.75. So now we can use this formula, and of course we can square root this to get sigma. So that's going to be 6428.75 divided by 56 square rooted, and that's going to give me an answer of 10.7. Now, when you look at the mark scheme, it actually states 2 answers. And the reason is this: when we're dealing with samples, really we shouldn't be finding sigma. We should be finding something called the unbiased estimate. and that is slightly different. Okay, the formula for that is s squared is equal to sxx divided by n minus 1 instead. So in other words, s is equal to the square root of 6428.75 divided by 55, which obviously gives you a slightly different number. Okay, now this is technically more correct, and really, I personally prefer this to do it correctly, because in biology, this is how we do it and things like that. So, both are absolutely fine. So stick to your guns, use what you're comfortable with, and everything will be okay. It's just printed twice on the mark scheme because there are two ways of interpreting. Okay, so 5 marks, and I'll show you where they're allocated. You get 2 marks for finding the mean, so you get 1 mark for demonstrating this. It's actually a method mark, and then an accuracy mark for finding the mean. You get an independent mark for finding the sum of fx squared. That means if you've made a mistake with the mean, you still get this mark, which is good. You then get 2 marks for doing standard deviation, and the key thing is a square root. If I don't see a square root, you don't get any marks for finding standard deviation. It's a key feature. Okay, so 5 marks for that part. Now part D is asking us to use linear interpolation to estimate medians. Now whenever you're dealing with medians, the most important thing is your cumulative frequencies. So that's going to be 6, 21, 32, 45, 53 and 56. I'm adding in my frequencies as we go along. And then again, there are some issues. To find the median value, I'm going to call it Q2. You could call it n as well. But Q2, we say, is the n plus 1 over 2 value. But also, you are allowed to use, because you're estimating anyway, I guess, you are allowed to use n over 2. Okay, so that's just an awareness. I'm going to use n over 2 because that's the predominant way on the mark scheme, and then I'll just annotate this just to show you what your answers would be if you used n plus 1 over 2. So this tells me that I'm dealing with the 56 over 2 value, which is the 28th. So the 28th value is in this category here. You look for the first cumulative frequency above 28, and that will tell you. So there now are 4 key numbers. 32 is the last member in the group, which goes up to 25.5. 21, the 21st value, is the smallest in this group. And again, we need to recognize that there is gaps in your data. So I prefer to do this graphically. So I have a group that goes from 20.5 to 25.5, and Q2, the median, is somewhere in the middle. 25.5 is the 32nd value, 20.5 is the 21st value, and my median is the 28th value. I then do this using similar triangles. So Q2 minus 20.5 divided by 5 must be exactly the same as 28 minus 21 divided by 32 minus 21. Okay, and if I see that, you've got a method mark. Even though it's different than what's printed on the mark scheme, this is perfectly fine. Of course it would be. Okay, so a little bit of rearranging. We're going to get Q2 minus 20.5 equals 7 times 5 over 11. Again, it doesn't matter where that over 11 goes. So Q2 would be equal to 20.5 plus 7/11 times 5, which is what's on the mark scheme. Okay, so if you calculate that, that's going to give you 23.7. Now, of course, as I said, you could have used n plus 1. Okay, so if you've used n plus 1, we're looking for the 28.5th value instead. So this would be 28.5. This would end up being 7.5, 7.5, 7.5, and you would get an answer of 23.9. So again, both methods are perfectly fine. So again, stick with what you've been taught, but please be aware that when you look at mark schemes, that's why they give you 2 answers. I think it's really important you appreciate that. So 2 marks, 1 for interpolating. Now, when we interpolate, it is absolutely critical that this number here is correct, i.e. demonstrating that you've dealt with the fact that it's got gaps in your data. Without that 5, you're not going to get any marks for this. So just be very, very, very aware of that. Okay. Now I'm going to go back now and look at part B, which I haven't done. And you're told there's a histogram that's been drawn. And these are not particularly pleasant questions. There are ways of doing it. I believe a picture speaks 1,000 words, so I'm going to do it by drawing something. So a histogram was drawn to represent this bar, and it had a width of 4 centimeters and a height of 6 centimeters. Okay? I know that the frequency of this group is equal to 15. Okay? Now, the other group we want to find the width and height of. So these are the physical dimensions. What we can then do, and I'll do this in a different color, is actually put in other dimensions. So the physical area of this is 24 centimeters squared, and its class width is 10. Okay? So that's really, really quite useful. So I can see, first of all, that 15 units is the same as 24 centimeters squared. That means I know that 1 centimeter squared is equal to 15 over 24, or 1 person is equal to 24 over 15 centimeters squared. So either way is absolutely fine. Now let's look at answering the question. Now we've got some additional information. So we're now looking at the 26 to 30 group. So that's a bit narrower. And there's 2 things I know. I know it's got an area of 13. So if it's got an area of 13, its physical area in terms of centimeters squared must be 13 times 24 over 15. Okay, and that's really, really quite useful calculation. So I know that the area needs to be 20.8 centimeters squared. Okay, now the width. I can see that the class width is in fact 5, which is half of the width of the previous bar, and widths are in proportion, so I know that that must be 2 centimeters. Okay, now because the area is 20.8, then the height must be the area divided by the width. So I know that the height of this rectangle must be 10.4 centimeters. Okay, so this is quite awkward. It's really awkward, and there's lots of different ways of doing this. So for instance, you're going to get 1 mark for making sure that the width is 2, just by recognizing that the class width is only 5 in this case. You then get a method mark for effectively working out the area in terms of physical units. And again, there are other ways of doing this, but that's what one method would be. And then, of course, dividing it by 2 and getting an actual answer of 10.4 gives you the actual answer. Okay, so I've done this question out of order because I wanted to show you this bit last, but that's how that one works. Okay, so the next question I want to look at is a box plot question, and this one in particular. It's got outliers, we have to draw a box plot, and we have to consider now outliers, so that's quite critical. So the first thing we could do with working out is the interquartile range. Okay, and the interquartile range will be 7 in this case. So before we really start drawing this, it would be a good idea to start thinking about your outliers. So your upper outlier boundary is defined as being, as it says, 1.5 times the interquartile range. So 1.5 times the interquartile range above the upper quartile. And if you calculate that, you get 24.5. Also, the lower outlier boundary is 1.5 times 7 below the lower quartile. Okay, which is minus 3.5. Now that can happen. Okay, there's nothing wrong with that at all. The amount of people that change that because they don't like it's negative is quite a lot. So what we then do is look at your data and see if we've got any outliers. And in this case, 25 is the only outlier. Okay, so it's a good idea to mark that first in my view. So 25 is an outlier. We can then start drawing the box plot. So we know that your lower quartile is 7, and we've got to be very, very careful making sure you read the axis properly. Okay, so 7 is here, Okay, so again, make sure it's clearly 7. Your median is 12, which is here. And your upper quartile is 14, which is here. Okay, so again, make sure that everything's in the right place. So you're going to then have your box, and then your whiskers. So your lower whisker must go down to 3, which is here, and your upper whisker. Now, I'd like you to do this properly, please. You know what your second highest value is. You know that your second highest value is 20. So there is no data between 20 and 25. So your whisker should go like this. Okay, and I'll talk about it again in a minute. But this is 5 marks. You get 2 marks for working out and demonstrating you've worked out your outlier boundaries. Okay, you then get a method mark for making sure that you have plotted the outlier. You then get an accuracy mark for effectively putting the right information in the right place, and then a B mark if you've only got 1 outlier. So if you accidentally had 2, you would lose that final mark. Now, I would like to point out on this, here's the actual question from the mark scheme, and I'll answer part B and C in a minute, but you can see there are 2 whiskers. Now, box plots never have 2 whiskers at one end, so there is an alternative. If you don't know what your next highest piece of data is, your whisker must go to the outlying boundary. Okay, so they accept it here. This bit is technically wrong, but it is a way of dealing with them, so they will accept both. My fear is that at some point they'll stop accepting both, so it is a good idea to make sure you're doing it properly. Now, it's asking you to state the skewness. Now, there are 2 measures of skew that we can use. If you write them in alphabetical order, your averages, mean is greater than median is greater than mode, so they're in alphabetical order. All of your inequalities are pointing in that direction, which tells me I have positive skew. If they're all the other way round, then I have negative skew. Likewise, if I put my quartiles in descending order, so Q3 minus Q2, Q2 minus Q1, again, if the arrow is pointing to the right, then I have positive skew. Now, you've got to choose the correct definition of skew. Now, in this question, I haven't been asked to work out the mean or the mode. In fact, really, you don't need the mode for this inequality, but it's there. So you are going to be using this second definition here. So you work out what Q3 minus Q2 is. Okay, you work out what Q2 minus Q1 is, and that's fine. So Q3 minus Q2 is 14 minus 12. Okay, Q2 minus Q1 is equal to 12 minus 7, which is 5. So we can say quite happily that Q3 minus Q2 is less than Q2 minus Q1. So as a consequence, we are going to have negative skew. So therefore, negative skew. And that is pretty much a perfect answer. Okay, we don't need to explain things in words, we can just use the mathematics to help. Now, part C. So you get 2 marks, 1 for saying that it's negatively skewed, and 1 for demonstrating you know. So you could use words, okay, but maths is much more efficient. So part C. The company claims that for 75% of the months, the amount received is greater than 10,000. Comment on the claim. Now, the first thing you've got to realise is, what this question is stating is 75% of the months are greater than 10,000. So they're really describing the lower quartile. Now, if we look at our graph, we can clearly see that the lower quartile is equal to 7,000. So what that implies is that there is less than 75% above 10,000. Okay? And we can see that because 10,000 is here. So what's the claim? So the claim is incorrect. So again, it's making sure that you've read the question and you understand that this is really talking about lower quartiles, not upper quartiles. Okay, so the other way of saying it is £10,000 is within the box between lower quartile and the median, so must be less than 75%. So there are lots and lots of ways of describing this. So just to finish with, here is just a quick question about stem and leaf diagrams. So we've got 19 employees, that's nice. Take an aptitude test, and the score out of 40 is illustrated. We've got to work out the median score. So you have to use n+1/2 here because you know all of your data. So that's 20/2, so we're looking for the 10th score. And it's literally just a case of counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Please then just have a look at your key. You can get into the habit of just going, oh, well, this must be 33. Just check that that's how it's to be interpreted. Okay, so that's going to give me 33. Now, the interquartile range obviously is about finding quartiles as well. So the lower quartile would be the 5th value, because it's half of the median, and the upper quartile would be the 15th value because it's 3/4. Okay, the textbook does something interesting with these, so you might get slightly different answers on more complicated questions, but generally speaking, if you just half the location of your median, that will give you the lower quartile. It's much quicker. So the 5th value is 1, 2, 3, 4, 5, 24. The upper quartile is the 15th. Okay, so again, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 40. And then the IQR in this case will be 40 minus 24, which gives me 16. Okay, and please remember the interquartile range is most definitely a number. Okay, it's a number. Don't just leave it as 24 to 16. So in total, this was worth 4 independent marks. Okay, so you get 1 mark for getting 31, you get 1 mark for getting 24, 1 mark for getting 40, and then rather nicely you get a follow-through mark here. So if you've made a mistake with your lower and upper quartiles previously, then you are sort of rewarded for that. Okay, so while we're on this slide, just to remind you, with this particular topic, there's lots of little variations to do. So finding the median, for instance, for group data, you can get away with using n/2, and you can use n+1/2. So just stick to your guns as to what you've been taught, and that will be fine. Standard deviation, again, you can either use n or n-1 as your total divisor, and again, just stick to your guns as to what you've been taught. Both are perfectly acceptable. Okay, you won't get penalised for using something that is slightly more accurate.